Hello everyone, welcome to Learn Overflow. In this video, we'll discuss another LeetCode problem, that is the number of dice rolls with target sum. This is a middle level problem where we'll understand step by step how we should solve this problem and what are the kind of analysis we can draw from this problem as well. So we'll see all those in this video. So before moving on, if you haven't subscribed to this channel, make sure to subscribe to Learn Overflow for regular LeetCode videos like this. Now the question says, you are given n dice. So that's like n number of dice are given to us, and each dice has k faces. So usually if you look at normal dice, a normal dice has 6 faces, right? But it's saying that this dice we have over here has k number of faces. So the number of faces we have is changing or is variable from case to case. Okay, and the faces are numbered for 1 to k, exactly how normally our dice are there, right? The dice faces are numbered from 1 to k, and that's how it is, right? Like usually we have 6 faces, and there we got 1 to 6, all the faces are there, right? Now what the question is further saying, like, we are given 3 integers. This is the n being the number of dice, this is the k being the number of faces, and a target variable being given to us, fine. We're going to return the number of possible ways, okay, to roll the dice so that the sum of the face up numbers equals target. Okay, since the answer can be too large, return 10 to the power 9 plus 7 mod 0. That's okay. So what we need to do, so the idea is you will be rolling the dice, right? As you know, as you roll the dice, any number can come up on the top, right? So whatever number comes on the top, that's what we call a face-up number, okay? That's the face-up number. And we should take the face-up number of all the k number of dice, okay? Sum of all the face-up numbers, and we should find out that when this numbers becomes a target, that is, all the face-up numbers becomes equals target, okay? So that will be our idea. We should roll the dice so that the sum of the face-up numbers equals to. So that's the idea. That's the whole question we have. Now, as an example, okay, as an example, if you just see over here, then you find that we have like n equal to 1, k equal to 6, and target equals to 3. So in this case, like n equal to 1, k 6, and target 3, in this case, we know that there's only one dice with 6 number of faces, and we need to reach a target of 3. How can we do that? Like only one way is there, right? Only one way that dice should be, our one dice should be rolled. That can give us sum of 3. In this case, not sum, rather the number 3 itself is coming 3 on the top, right? There's only one case possible. Okay, so that's why answer is 1. In the other case, you see like there are two dice, and in 2 dice you have 6 faces again, and you need to reach a target of 7. So how can you do that? You can do that with 1 and 6. If this other 2 dice faces are there, then you got 2 and 5, then you got 3 and 4, and the reverse, 4 and 3, 5 and 2, and 6 and 1. Okay, so this is the kind of target we can reach. Now, by looking at this kind of problem, what you can come up with is, if you remember, there was another problem we have. Uh, that problem, if you remember, a coin change 2 problems. So this is the problem we had, okay? And this is the problem kind of have the same kind of approach where we are given these coins and we need to come up to this amount. Okay, the sum of the coins should be about equal to the amounts. And here in our current question, if we see, we have n dice, okay, and our sum of the faces, okay, our sum of the faces is should be our target, okay. Similarly, if you just try to correlate it with over here, then you will find out that the number of coins, like the number of coins is actually the array is given to us. So we can find the length, that's the number of dice is given to us. And similar way, the value of the coins, that is the face of in our dice, is somewhat equals to the amount, like sum total is the amount. But there's a difference. The difference is what, the difference is there in the combination. Okay, this is the combination that we need to do. Like not the combination, rather the permutation we need to do, because here the reverse is also true. 3 plus 4 and 4 plus 6, both are getting counted. Now this is the trick that you need to find out. Else, if you try to figure out, the problem will be looking more or less on this way. But this is not the exact way we should be finding out. We should be going ahead. We should need to take care of this kind of permutations over here. Okay. Now let's try to understand the problem with some other examples. Okay. Some other examples, if we just take, say, So we just, as we understand, we need to take an DP array, or if we just try to understand it in normal sense, okay, right? I'm writing DP. Let's not think of DP as dynamic programming. Just consider it's a name I'm giving it, okay? I'll explain it to you how we can come up with this solution, okay? Now let's understand this one. So if we just consider our function DP, fine. A function DP is like a n being the number of dices. Then we have k being the being the like the current phase value, and then we got our target, right? So I'm writing a target as t, right? So this is what we got. Now, what if we need to reach a value, something like say we have a DP, in that we got like 5 dices with each phase value as 6, okay, as 6 being the possible phase values, and we need to reach a target of 18. Fine. If this is the target we need to reach, then what can be done? Okay, let's try to analyze this. Then exactly what can we do to this? Now, we need 1 dice. Okay, let's consider 1 dice out of it. So how many dices are remaining to us? Okay, so if we are taking 1 dice, then we are 4 dices need to be adjusted. Fine. So if the last die we have, if the last die got 1, okay, the last die can be 1, the last die can be 2, right? The last die can be 3. I'm just considering 1 dice out of this 5, and that makes it like the 4 dice are remaining that needs to be considered, and now I'm considering all the cases that can be done for the last 1 die. Okay, now the last die can have 6 values, right? So I'm just writing out all the 6 values that the last die can take. So this is the case our last die can take. Now, if our last die got 1, fine. If our last die got 1, then what is the sum that we need to reach? That is our target. Our target becomes like 18 minus 7, like 18 minus 1. So that remains us to be 17, right? That's our last die can reach. I mean, that this 17 needs to be fulfilled by the rest of the 4 dice. Now, so what leaves us with? Leaves us with a TP of what? 1 die is used. So we got 4 more dice to be used, right? And with that, we have 6 phase values, and we need to reach a value of 17 with this 4 phase values, right? Now, if our last die got a value of 2, so in that case, we got 18 minus 2, so that remains a 16, right? And in that case, we find out if our DP case, like our consideration will be, we got 4 more dice to check, and they each got 6 phase values. And with those 4 more dice, we need to reach a value of 16. That will be the case if our last die got a value of 2. Similarly, if our last die got a value of 3, we'll see that we need to reach a value of 15. And in ultimately, what we are left with, we are left with DP of 4. That is 4 more dice are left with each phase value of 6, and we got 15 sum to be come out from the other 4 values, right? So this is the way. Similarly, if we just keep tracking, so this is the kind of case we are reaching if we just look one by one into this whole thing, okay? So if we based on what our last die is taking, we are finding out we got like 6 ways to look into, okay? Now, in this 6 ways, we find that we need to reach this sum based on that, right? Now, here is the whole catch of this question. In this catch, like if I think you are now able to visualize what is the exact steps we need to do. We need to go ahead from each of the die 1 to n. There's a loop going on, and in that, from each of the die, we need to keep subtracting the phase values, one by one the phase values, right? And we need to try to reach our exact target. Okay, if you are getting to reach your exact target, that's how we are getting the values, right? That's how we are getting to know, like after if I just take the 6th case, like the last case, then we know that with 4 more dice, I need to reach a value of 12. Thus, we can reach our target, right? This is the thought process behind this. Now, as we know that we sum up the solution of this 6 all cases, like all the 6 cases to arrive to our result, right? And of course, each of these cases branch up into like 6 cases of its own. Like each of the dice we got will again branch up into 6 cases of its own, and the recursion will also resolve into something called d equals 0. That is, the number of dice should be at last ending up to somewhere around 0, right? That should be the case that will actually end up to. So that's what we need to handle as well. because we're reducing the number of dice. So if we need to handle as well, now what exactly is a formulation? Can we come up to any kind of formulation? The formulation is, we need to see if we are trying to find out DP of 5, 6, and 18. If that is the case we are trying to find out, in that case, what is DP of 5, 6, and 18? Is basically equals sum of the, like, all these things, like all these things being summed up. Okay, like all the 6 cases being summed up. So that's the DP of 5, 6, and 18. So that's the question over here. Now, as we know, like we are trying to figure out the exact question, okay, like trying to figure out a formulation for this particular question. Now, what if we have DP of n, k, and t? Okay, if we just know DP of n, k, t, okay, just as you understand, like this is like the sum of all the values. Okay, so let's try to understand DP of n, k, t. Fine. Now, this is the exact case we end up with. What it is, we got dp of nkt, that is dp of n minus 1 k target minus 1, n minus 1 k target minus 2. And similarly, we'll keep on adding all the values to dp of n minus 1 k target minus k. So that's the value we'll end up with, right? Because we have 6, so target was 18 minus 6, that is 12. So that was the last case we'll consider over here. So that's the summation we need to do, right? So if that is a summation we need to do, then we know that we are simply going on a loop of k, right? We are just subtracting k as well. So that's the condition we need to think of, and that's how we will solve this question. So just remember this formulation, okay? How we derive this formulation and how this formulation is actually ending up to this solution. Now, why DP? So if you look carefully, what exactly we are doing in this question, we are just like we're just going through all the values over here, right? We are going through each of the dice, and each of the dice we are checking for all the 6 cases into our dice, right? So that's what we're going into now. That results in a much larger values, or much larger, you can say, a tree or a recursion will keep on traversing all the values, right? So is it actually necessary to keep on traversing all the necessary? Like here, we are simply keeping some of the values in our like DP array just to for further checks, and just for finding out what is the previous value. And based on that, we'll keep checking further. So that's the idea. That's the whole idea behind coming up to a DP. Because if you just try to do it in a brute force way using this exact formulation, it will work. I'm not sure whether it will give you a time limit exception or not, but it should work. Okay. So the idea we should go ahead with, we should keep on breaking the values and ultimately finding a solution to that. Okay. So that's how it is. Now, this is the kind of, as we were saying, this is the kind of top-down approach you are going down. Like we got n and we're breaking down into 0, like top-down. But it will be much easier if you just start in the reverse order. What? If you just start from 1 and just traverse to n. Okay, so in that case, it will be much easier to understand how it's going. Like here, we are starting from n and we are breaking it to like 0, right? Where 0 is the base case, and we will stop our like calculations further, right? So in that case, like bottom up will help us, or it will be much easier to understand. Let's quickly go ahead with the bottom up approach of writing. As I understand, this will be the exact similar cases, nothing much different in that. Okay, you just need to control the like handle the edge cases, and that's all it is. Let's quickly write our code and understand how this can be done. Okay. There you see, this is a like 19% solution. Let's understand what exactly we did. We, as you know, we just took an DP array, and this is a long time array we took, okay? Because as you know, by default, our answer is going to be large. We are expecting it to be large. So just take it long. And obviously we did our modulation as well. That's not the case. Now, what exactly we are doing with this DP array? See, the DP array is of length, a target plus 1 and n plus 1, n being the number of dice. See, as I said, like we had that, we have drawn that DP of like n, k, and target. So in that k is like constant for all, right? We know k, and we shouldn't be having it in our DP, right? So that's how we didn't took it in our DP. We simply had two variables, target and our aim, being the number of dices we have. Now, The first thing is we are taking dp of 0, 0 as 1. Why? dp of 0, 0 is kind of the best case. What it means, we have 0 dice and you need to reach a target of 0. Then how many ways you can do that? If you have 0 dice and you need to reach a target of 0, that means you can reach it, right? You can reach it with one case, one condition only. So that's what dp of 0, 0 represents, and that's the base case for us. Now, what exactly we did? We got our values like I equal to 1, I less than equal to target. So we just ran our loop of I from 1 till target. Now 1 till target is like having all the target values, okay? All the target values, because what target we are trying to reach. That's the case. Now next, if we look what else we have within that, we're traversing a loop of j, and that loop of j is from 1 to like j equals 1 to j less than equals n being the number of dice. That's exactly what we're doing. We as we saw, we got we, as I said, like we had n equal like dp of n, k and t in our example, right? Now over here we're doing is like from dp of like n being traversing from 0 till n, or traversing from 1 till n, right? So that's what we are actually doing in this case. We're just traversing for all the things. And now we got another variable, another loop variable, that is the role, and this role is basically role is I till role less than equals k. Why is it so? Is it because we're just checking for each of the phases, right? For the phase value 1 and phase value till phase value equals k. So that's what we have, because role is like phase value is moving from 1 till k. So that's what we do, right? I just named this as a phase value or the role. Now, there's one other condition that is like dp of I minus role is all should be greater than equal 0. Why is it so? It will be used over here. Now let's understand what exactly we're doing. We're doing is something like dp of ij being our current position, our current target, and our current the current dice we have. Okay, j being the current dice. Okay, what we're doing, we're just trying to find out what we're trying to find out is like, let's see. First thing is j minus 1. As we saw, like we saw in the examples that we had a dp of examples was like dp of n, there was k, and there was t, right? So this was the condition we're going ahead with, and in that we got something like dp of n minus 1. Remember, that was the case. N minus 1 is common to all, so that's what j minus 1 is common to all, and then k remains constant, so that was not the case. And then the last case we got was t minus k, right? So that was the last case, and so that's what we're doing. So k is not a value over here, so in place of k in that, we got a variable called role, and this role is actually a variable that is running from 1 till k, right? So we're just subtracting what this target minus our target minus our role. So see, that's what it is. The target is what is our current target, 1 to n, and now I minus role is actually giving us target minus our previous value. Okay, so that exactly that is the step we are traversing over here. And after we are done with all the roles, we just got values like we just did a modulus to just make it useful for us or make it within our range. Ultimately, once we're done with this whole loop, we just simply return this dp target, and that's done. And that's the solution we are looking for, right? That's the exact kind of solution we are looking for. Now, if you, as I said, our problem was more or less similar to our previous case, right? Or the previous problem we had. So if you just look in that previous case, see, in that like point change problem, we had a similar formulations, that is like k minus c. So that's the kind of formulation we need to find out. Okay, that's what we actually tried to figure out, and that's how we found out. The formulation is kind of different also because the question is different, and obviously the ask cases are different, but the similarity is there. Fine. So that's what I'm trying to find out. So I hope this is understandable. If you couldn't understand the analogy between that both the questions, as I said, the points is you should be bothered about it. If you can understand this question clearly, it's good to go, right? So thank you all for watching this video. If you have any doubts regarding this question, make sure to put them in the comments as well. I'll be happy to help you out in the comments. So thank you all. Hope to see you soon in my next video as well. Thank you.